Hello everybody, here we are and let's get started and we are gonna be continuing from where we actually left earlier. So without any further delay, we were mainly talking about the consumer groups. So this is the time to just simply create the consumer groups, and once the consumer groups are actually created, then we are gonna be just simply using them, we are gonna be reading. So when the task at hand is to consume the same stream from different clients, then XRead is already offers a way to fan out to n clients, potentially also using replicas in order to provide more read scalability. However, in certain problems, what we want to do is not provide the same stream of the messages to many clients, but to provide different subsets of messages from the same stream to many clients. An obvious case where this is useful, that of messages which are slow to process, the ability to have n different workers that will receive different parts of stream allows us to scale message processing by routing different messages to different workers that are ready to do more work. Pretty simple, understood. Then in practical terms, if we imagine having three consumers C1, C2, C3 and a stream that contains messages 1, 2, 3, 4, 5, 6, 7, then we want what we want is to serve messages according to the following diagram. So consumer 1, 2, 3, then consumer 1 will take 1, then 2, then 3, then consumer 1 will take 4, then 5, 6, and the 7. So ultimately this is how it will just simply keep going on. So there are going to be multiple workers, ultimately consumers, and hence we need to create something called consumer groups. So this is how it just simply goes on. Pretty understandable. Let me switch on the fan first of all because it's hot here, and after that I'll be back. Alrighty, so let's continue. The fan is on and let's keep reading. So in order to achieve this Redis uses concept called consumer groups, it is very important to understand the Redis consumer groups have nothing to do from an implementation standpoint with the Kafka TM consumer groups, yet they are similar in functionality. Okay, they are sort of similar in functionality, so I decided to keep Kafka's TM terminology as it originally popularized this idea. So a consumer group is like a pseudo consumer that gets the data from stream and actually serves multiple consumers, providing certain guarantees. Each message is served to a different consumer, so that it is not possible that same message will be delivered to multiple. Uh, each message is served to a different consumer, so that it is not possible that the same message will be delivered to multiple consumers. That's right. Consumers are identified within a consumer group by name, which is a case sensitive string that the clients implementing consumers must choose. Yeah, that's you just need to give the name. That name can be ID as well. This means that even after a disconnect stream, consumer group retains all the state, since the client will claim again the same consumer. However, this also means it is up to the client to provide a unique identifier. That is also right, understood. And then each consumer group has the concept of first ID. Each consumer group has a concept of first ID, never consumed, so that when a consumer asks for new message, it can provide just messages that were not previously delivered. That is okay. First ID never consumed. Okay, fine. Consuming a message, however, require an explicit acknowledgement using a specific command. Redis interprets the acknowledgement as the message was correctly processed, so it can be evicted from the consumer group. So ultimately what happens that uh, after getting the message, you will have to acknowledge this. So consuming a message, after consuming the message, however, requires explicit acknowledgement using a specific command. So you will have to acknowledge that. Redis interprets the acknowledgement as this message was correctly processed, so it can be evicted from the consumer group, so that it can actually be removed from there. Okay, and a consumer group tracks all the messages that are currently pending, so that is messages that were delivered to some consumer of the consumer group, but they are yet to be acknowledged as processed. Thanks to this feature, when accessing the messages history of stream, each consumer will only see the message that were delivered to it. So ultimately, whenever you are getting the messages which got delivered to this, you are going to be getting all the messages, and if they got acknowledged, they are going to be removed, something like that. In a way, consumer group can be imagined as some amount of state about a stream. So there's gonna be, what time is it? 5:38. Okay. So there's gonna be consumer group name, and there's gonna be consumer group stream, some key over here, last delivered. Then we will have many consumers under that. So consumer 1 with the pending messages, these the consumer 2 with pending messages, something like that. And if we acknowledge them, they will keep getting. If you see this from this point of view, that it is very simple to understand what consumer group can do, how it is able to just provide consumers with their history of pending messages, how consumers asking for new messages will just serve with the message ID is greater than last delivered ID at the same time. If you look at the consumer group and as an auxiliary data structure for the Redis streams, it is obvious that a single stream can have multiple consumer groups. A single stream can have multiple consumer groups that have different set of consumers. Actually, it is even possible for the same stream to have clients reading without a consumer group via X read. So it is also possible that have what it is even possible for the same stream to have clients reading without consumer groups via Xread or clients reading via Xread group in different consumer groups. Okay, now it's time to zoom in to see the fundamental consumer group commands. They are the following. X group is used in order to create, destroy and manage consumer groups. So if you want to create, destroy and manage them, so we use X group. X read group is mainly used for reader from stream via consumer group, that is fine. X hack is the command that allows consumer to mark pending messages as correctly processed. Sorry, this is hack. So using this command you can mark them as correctly processed. X hack delete combines acknowledgement and deletion in a single atomic operation with enhanced control over consumer group references. So creating consumer group, if you want to create a consumer group, so you can just simply run this command, use this method over here, and this is the key name, this is the name of the consumer group, and then you will use dollar over here, that simply means it will start from the current one. And similarly we have we can even make a stream to, what does it mean, I have to go through it anyway. Assuming I have a, if I keep going through it like this, it will be taking a lot of time. I do not have that much time, hence we will be just simply having a quick look at this. Especially this part is done, so we don't really need to worry about it, especially the part of creating the new consumer. And I think we even don't have this option over here. For creating the consumer, here I used this command line interface, and especially in this command line interface, instead of having India over here, we are going to be having the ID of the region, so that using that particular region we can just simply find the group. So this is how it's going to be going ahead. And apart from this particular thing, consumer groups are here, so let's simply go through this. So we are going to be creating a consumer group. Once the consumer group is actually created, we can even make stream. What does this mean over here anyway? mkstream. So X create group also support creating a stream automatically if it doesn't exist using the option mkstream sub command as the last argument. So it will be creating the stream automatically. Okay, that's fine. And going ahead, this way we can create once a particular group is created, we'll add the, then we can just simply X read group. So using the group name we can just simply read them, and as we are reading them, then they are gonna be read, hence they are gonna be removed as well. Of course we'll have to acknowledge them as well. So X read group Italy, they did this, and once that is done, so acknowledgement is also there. So however, if we acknowledge the message as processed, it will no longer be the part of the pending history, so the system will no longer report anything. The thing is pretty simple, that at the end of the day, you have this queue. These workers, ultimately there are going to be consumer groups here, so you can create multiple consumer groups. For example, we'll have a consumer group for India, we'll have a consumer group for USA, and they will have workers. So that can be worker 1, the name can actually be anything, depends on you. So suppose they have worker 1 just like this, so they have their own workers. Those workers, consumers, ultimately will be responsible for getting reading. So ultimately using consumer group, I'm gonna be just simply reading the queues, the whatever there is inside this particular queue. Once I got that, I will process that, and lastly I will acknowledge that. Acknowledge means everything has been processed successfully, so remove that particular request from the queue. So this is how it's gonna be going on. So workers are gonna be just simply getting what? Workers are simply gonna be getting the request, and they are gonna be getting the request like using this xread group command. So hopefully I must have it here, right? So yeah, this is the command ultimately that's here. So xread group is the command that will mainly be used for reading. So when it comes to reading, so we need to know the consumer group name, whatever the consumer, we need to know the worker ID, and we need to know the stream name. That's actually better stream, better uptime column website here. This greater than just simply shows that what it shows. It has to just get everything from. Okay, I'll have to dig deeper into it. I forgotten the use of this anyway. Let me see. Okay, I haven't even written this thing here. That's insane. Never mind. I'll be writing it again right here. And apart from this particular thing, this does something that I've forgotten, but never mind. And then count, ultimately we are gonna be getting 5. And once we got them, so ultimately we are gonna be reading. Once we read them, then we are just simply getting the process. We are just simply gonna be returning from here. So once read, we are gonna be returning the result from here. That result will have messages. Those messages are gonna be having what? Those messages will have the ID and the message in them. And ultimately what will happen as we get the response. First of all, let's check this thing out. ID here. What does this ID do? So Redis streams. I need to dig deeper into it anyway. So this is where it's used. So let's simply go through it. So don't worry if you don't know how to acknowledge works. This idea is just the idea is just processed. Messages are no longer part of history that we can access. Okay, now it's Bob's turn to read something. So X read group this. Okay, so what does this do? Where all it's being used just right here, but what it actually does. Okay, Bob asked for maximum two messages is reading by the same group. So what happens is that Redis reports just new messages as you see the. Okay, I think this is mainly used for getting the new messages if I'm not wrong. As you can see, Cashlia message is not delivered since it was already delivered to Alice. So Bob gets okay, Sam's and so forth. This way. Okay, let's do one thing. Come on, I can't even copy properly. Let's wait for a sec. Okay, let's simply copy it, and here I'm gonna be use of this. That's it. Good question. This is actually very important in Redis streams. That is right. This is very important. Meaning of this command is give me only new messages that were never delivered to any consumer in this group. Pretty simple. It just simply gives you new messages. As simple as that. So pretty simple, interesting. And apart from this particular thing, what if we want pending messages instead of this? Use an ID like this. So this just simply gives all the pending messages. Gives me the already delivered messages. So ultimately all the pending ones we get. And so this normal consumption like a queue, recovery, retry, acknowledgement messages, that's fine as well. Okay, understood. So this is mainly used for getting the new messages, and once we got the new messages, so we got the response, and at the 0th index we have the messages. Those messages contain this type of data. So ultimately I'm gonna be having ID and I'm gonna be having message here, and ID in the sense ID of that particular request and whatever we have in the queue, and this is just the identifier that contains the timestamp and the sequence number, and then we have the message that has actually the URL and the ID excuse me, that we actually stored in the beginning. Okay, so this is how it's gonna be going on. Pretty simple, and we can even read through it. So at the end of the day, we are just simply using this X read group, right, to just simply read. And as for this particular command, so if you actually come here, this is the same command. By the way, let me switch to just a minute. It turns out that I'm gonna be suffering from sneeze a lot. Okay, never mind. I hope I will be suffering less. So over here, when it comes to reading it, so consumer groups, it actually starts from here, and if I just keep scrolling, don't know how long. Just a minute, give me a second. Let me freshen up. Alright, everybody, welcome back. Let's continue anyway. So here we are, and when it comes to that particular command, so this way we can just simply create a group, and once the group is created, this way we can just simply read. We need to know the key, we need to know the group name, and this is how we can just simply get the job done. Here we were reading as well. No, we created it, and then the group can actually be created like this. When it comes to reading, so we can actually add first of all. So here we are just simply adding. Once added, we can just simply read. So this is how we are just simply reading it here. Okay, pretty simple. The same things are getting done here as well. So first of all, okay, just a sec here. So first of all, we are just simply adding. Once added, we are just simply reading. So thanks to this documentation, makes everything understandable. So yeah, that's fine. So once we have read, so reading is just not enough. So once we've read all these things, so ultimately what we are doing here, that X read group is just simply gonna be reading everything using the region ID and worker ID, and in the response you are gonna be getting the array of all the messages, call them messages, call them requests, whatever you want, but you are gonna be getting the result in the form of an array. Once you get the result in the form of an array, so ultimately you will have the ID there. So you can acknowledge that. Acknowledging in the sense, this is something I have processed, now remove it from the queue. So for acknowledging it, this is the command you have here, acknowledge. So acknowledge, you need to have the key, and then you need to have the name of the name of the group ultimately. So name of the worker, name of the worker or the group. Uh, you need to know what, yeah, you need to know the name of the group, and then you need to have the ID, and this is how it's gonna be done over here. Pretty simple, and the same way it's been mentioned here as well, if I'm not wrong. So when it comes to acknowledging, reading the group, acknowledging, so whenever we are acknowledging, we need to have the key, we need to have the group name, we need to have the ID of that particular message or the request, call it anything, call it message for now. So we just need to have the ID of that particular message, and once we acknowledge it, that simply means it has been processed, and the job is done. It's going to be removed from the queue. So we started from adding to the queue, reading from the queue, acknowledging it so that it gets removed. So once this is done, so again this response is nothing but an array, so we are just simply looping through that. As we are looping through that, so we are going to be getting messages, and once we are getting messages, so we are using we are fetching the website using this particular function, and at the end of the day, whatever is returned from here, that becomes the part of the result of the map, as simple as that. So this map returns the array, so whatever this fetch website returns, that is sort of the value of the array. Okay, so this is how it just simply goes on. So promises, this is gonna be an array, and this is gonna be the array of fetch websites, this particular thing over here. And when it comes to this fetch website, so what exactly am I doing here? So we have the URL of the website, we have the website ID as well, and now we have a promise running over here. So because again, this promise will be responsible for getting the data saved in the DB as well. So what we'll do, this is the start time. I'm gonna be making a request to the that particular URL, because we have to check whether that is up or not in every 3 minutes or something. And if that is up, if everything goes right, in that case this is gonna be the end time, and we are gonna be saving it in the database. In the database we have the response time, status, region ID, and website ID. All these things are gonna be stored here, and if that fails somehow for some reason, if that succeeds, that's gonna be up. If that fails, that's gonna be down. And this is how we are gonna be getting the job done. The interesting thing is that this whole thing, though we are getting this particular stuff done here, but this is actually a promise. So sort of a promise gets returned from here. This is something honestly I'm not quite good at understanding. Like, okay, it just does make sense that okay, you are returning a promise, and then once the promise is actually returned, then if first of all you are checking whether you are using a you first of all you are checking whether everything goes right or not. If everything goes right, that's great, otherwise just simply catch the error and return, and ultimately a promise gets returned. But I want to understand it deeply, hence I'm gonna be using ChatGPT here. Explain it to me. So what this function does, big picture, fetch website checks if a website is working or not. It measures response time, saves the result in the database using Prisma. So async this URL website, you want to check website ID used to store a result in DB. Promise wrapper, you are manually creating a promise. This lets you control when the function finishes. So note, since you are already using async, this wrapper is not really needed. Start time, let me give it to give it this, the whole thing that we have here, and now explain this. Okay, now this is basically worker service that okay, that's fine. Queue jobs, so ultimately they can be called request jobs, so yeah, they are mainly jobs. From a queue processes them and stores the results. So big picture, this is a background worker for enough time monitoring system, that is right. Read jobs from the Redis stream, so it does that. For each job, check a website, save the result in the JB acknowledgement, job back to Redis, that is right. And step by step explanation. Environment variables, that is fine. These identifies region ID and worker ID. Main starts it, so ultimately main function starts the worker. And validation, first of all we are validating it, that is also right. Infinite loop, it just this keeps the worker running forever, continuously pull jobs from the queue, that is right. Read from the Redis stream, so ultimately we are gonna be reading from the Redis streams. This is likely a wrapper, that is definitely right. Meaning read new messages, assigns this to worker. And if no response messages, then continue, skip and try. Response structure is gonna be sort of like this, that is right. Each item looks like this, that is also right. Process all jobs in parallel, so ultimately it's gonna be processing all jobs in parallel. It's not awaiting. This is a map, so it's gonna be just simply processing them. And for each message, call website this and parallel execution, so await promise dot all parallel execution. So all requests runs concurrently, much faster than sequential, that is okay. Acknowledgement, we are just simply acknowledging using the region ID and all. Ultimately this will keep going on. The problem is not the problem, actually the question is that as we are creating a new promise, so does it mean whenever the fetch function runs, so whatever the logic is inside the new promise of the fetch function, that doesn't run, and whenever we are just simply awaiting in all the promises, at the time it runs. This is where I'm confused, so I'm gonna be knowing more about it. So yeah, let's simply go ahead. And this is very common confusion. Okay, no, the code inside new promise runs immediately when the function is called, not when you await it. So let's break it down. You are thinking, does the logic inside promise run later when we do this? The assumption is wrong. What actually happens over here, that whenever we are just simply going through this, when this runs, fetch website is called immediately, inside a new promise is created and its executor function runs immediately. So important rule, new promise resolves to this, this runs immediately, this function is not delayed, it executes right away. So in your code, when you do fetch websites and URL ID, this happens instantly. Date.now access this request has already started. Then what does this promise dot all do? It does not start the execution, it only waits for all already started promises to finish. So it just simply waits all the promises to finish. Timeline, I mean there can be multiple timeline, very important. Map runs, so like this all API call start immediately parallel. So the benefit of using this is simple, pretty simple. That is when I'm using this particular fetch function over here, so it gets called over and over, and as this gets called over and over here, so at the end of the day I'm just simply returning this promise from here. And the main reason behind returning the promise, so that I can await all the promise over here, as I'm awaiting all the promise, so that once all the promises have been resolved, how will they be resolved? They will be resolved when everything actually either it succeeds or it fails. So in any case it will be resolved, and when it's resolved, not only one, when all of them have been resolved, only then this particular promise dot all is gonna be running. Hence it's gonna be working as expected. Now you wait for all of them to complete. Simply think of it like fetch website is starting a task, promise dot all waiting for all tasks to finish, and that makes sense. Okay, understood. So ultimately this promise doesn't really do anything except one thing, that is it makes sure that everything runs, and when everything runs, the promise gets resolved, and ultimately a promise gets returned from here. Once a promise gets returned from here, I'm gonna be waiting for all the promises to be resolved, only then I'm gonna be going ahead. Okay, and then at the end of the day, once I've done this much, so ultimately when I resolved all the promises, resolving all the promises in the sense I made a request to the database, and I just simply saved, I made a request to the server, got the result, and saved the data in the database. Once that is done, then we actually acknowledged the region ID, and we sent the response.map and the ID. So ultimately, this is the ID of the process, this is the ID of the job, and the region ID is being sent, because these are the two things that we actually need when acknowledging. So when it comes to acknowledgement, so we already have the stream, we need to know the consumer group name, so we need to have the ID of the job. So this is the ID of the job that we are passing, and here we are just simply sending the whole sort of an array here, and in here we are just simply gonna be looping through the event IDs, and we are gonna be acknowledging them one by one. So this is how the job is gonna be done. Pretty simple, understandable, okay, makes sense. So this is what we've done here. So what all we've done, first of all, coming back to this one, client just simply saved everything in the database, user info, website tick, region tick, all these things. And ultimately what happens, that from the DB I just keep getting the website info in some intervals, and I'm gonna be pushing that job to the queue. Once that is pushed, then workers are gonna be getting the jobs one by one. They are just simply gonna be processing the job, and once the job is actually processed, processing the job in the sense saving processing the job in the sense they are gonna be saving the making the requests and all. So let me have like this. Processing means what? Making a request to server and saving info to DB. So this is how it's actually gonna be going on. So these are the few things that needs to be done just in the processing section. So let me make it this here. So ultimately this particular section that will be done in the process. Process means this whole thing, making a request to the server, and once this is done, this process is actually gonna be saving the data in the website tick here. So the data is gonna be saved in the website tick. So this is how it's actually gonna be going on. So it will be just simply save to DB. It will be saving ultimately save to DB, just like this. So it will be just simply saving to the database. Once it has actually saved the ticks to the database, so if I actually show you this thing here, so we returned everything, and inside the worker, ultimately over here, whenever we are fetching, at that time what we are doing, we are making a request to the DB inside website tick. So inside the website tick we are actually storing the information. Once the information is actually saved over here, then we are gonna be acknowledging. So once all these things are done, we are gonna be acknowledging. So we are gonna be acknowledging jobs. All the jobs are gonna be acknowledged. That simply means once acknowledged, they are gonna be removed from the queue. So ultimately, when the jobs are acknowledged, means removed from queue, and new jobs are gonna be there. So this is how the overall things look like. This is how the overall diagram looks like that I created in the worst way possible, but okay, it does make sense, right? So in order to get this thing right here, I can just simply copy it as PNG. Once it is gone through the overall code of the worker, exactly how the worker works. We've gone through the pushers, we've gone through APIs. The last one is the test. Test is pretty simple. We have the website test, we have the user test, we have the test utilities, forget about that. We have the test config, forget about that. Mainly two things. We are testing the user info, we are testing the website info, and here we are using the gist. And it's pretty simple. Again, we are using bun over here. Bun has its own testing. It's just like gist or vtest, but we get all these things from the bun side by default, so we are using it here. So ultimately, when it comes to testing the user, so it's pretty simple. What we are doing over here, this is the first suite, this is the second suite. The two suites we have here. First one is the for signing up, second one is the for signing in. Inside the suites, we are gonna be having some tests. So this is the first test and this is the second test. Here in the first test, what we are saying, it isn't able to. It should be actually in small case. So it isn't able to. Forget about isn't. Let me make it shouldn't. It shouldn't be able to sign up if body is incorrect. If the body that you are providing that is incorrect, that simply means there is no body, then you should not be able to sign up. So I'm just simply making a request with this, as I'm using a try catch block over here. So what will happen, it will definitely fail. At it fails, this error section is gonna be running. So this expect is never gonna be running. So expect is false over here. Control shouldn't reach here ever. If the control is actually reaching, so it's actually gonna be false, then that's gonna be problematic, because this will fail. So this particular section is either section is gonna be running, that simply means this spec is never gonna run. As this never runs, so ultimately it's gonna be true. Similarly over here, and is able to, so should be able to sign up if body is incorrect. So we are just making a request, we are using a try catch block. It is definitely gonna be, it should succeed. That simply means it should not throw any error because we are passing the body over here. We are gonna be expecting the whatever response we get, if that is equals to 200 and the id is defined over there, then that's okay, it is right. So it's pretty simple. First of all, what you have to do, you have to keep few things in mind here. First of all, the AAA format ultimately act acknowledgement, I forgot the full form, AAA full form in API testing, AAA in API testing. Arrange, act and assert. So first of all, what we are doing over here, arranging means what kind of result you should be getting, and arranging, then here we are not actually arranging it here, rather we are just simply acting, and then we are just simply checking the result, asserting the values and all. So this is the first thing that got done. Similarly, another one must have got done here. So this is the suite that we have. Just below that I have two cases. In the first one, I am just simply making a request without the body. That simply means the first section should fail. As this fails, this error is gonna be running. Ultimately there is no expect, so it is fine ultimately. And we could have some expect over here. So expect in the sense of expect and what error, I mean actual, ultimately even if we have no what can I say, if we don't have any expects, if we are not asserting here, that is also fine, because if we are not asserting, that simply means if nothing expected did not run, that simply means it failed. So it should this particular section should be failing at the end of the day. Pretty simple. Just a minute. Alright everybody, let's continue. So I just simply went out for a break. Okay, coming back to this one. So here we are doing the same thing. We are just simply passing the body over here and we are expecting the result of, and that is it. So if the result is found, then simply means it succeeded. And when it comes to website, so we are doing the same thing over here. We have two suites ultimately. We have the website gets created, can fetch the website. So we are creating the website, we are fetching the website. In both the cases, we are getting the job done. When it comes to creating the website, it's pretty simple. Before anything else, because if you want to create the website, you need to be authenticated. Without being authenticated, you cannot really create the website. So before all, I'm gonna be creating a user, and this is nothing but a function that I have since I test utils. This is just a function. So I'm getting the user information. So like I'm just randomly creating the users. Once the users are randomly created, so we are first of all signing up. After that, we are signing in, and after signing in, we are just simply returning the ID and token from here. ID I'm gonna be getting after signing up, and token I'm gonna be getting after signing in, and this is the JWT token. That is pretty simple. Once this particular thing is done, so ultimately I got my token, I saved my token over here. So before anything else ran, I ran this particular part over here. So ultimately I got the token. Once I have the token, I will be able to verify myself. So website is not created if the URL is not present. So when you are creating the website and you are not passing the URL, so this should definitely throw the error. So this expector should never run, because ultimately this part is going to be throwing the error. Hence this is going to be pretty simple. It is definitely going to be right. And the another thing is that a website is created when the URL is present. So if you are actually are giving it the URL, so it should not fail. Hence you should be getting the ID, and whatever ID you are getting, it should be not null, or it should be defined. You can just simply have anything here. Okay, so this particular thing is done. Website is created if the header is present. So whenever you header is present, where is the header? Just a sec. Website is created, or website is not created if the header is not present. We are not making the header authorization token. So ultimately header is not present over here, so it should not be created. So if we are just simply sending this much, so this particular part should never run. So this is how it's gonna be going on. There was a mistake. Website uh, is not created if the header is not present. So this is how it's gonna be going on. By the way, this is not the best way. It should be like, it should never create a website if the header is not created. The best way could be, it should not create a website if the header is not created. This is the right way to write the this message here. Similarly, website, forget about that, we can just simply get that right anytime. So these are the things that we have gone through. So this is the first suite that we've gone through. The second suite, fetching the website. When it comes to fetching the website, so of course we need to have the tokens, and when it comes to having the tokens, so of course we will have to create the user, not even creating the user, yeah, you will have to definitely create the user. So you'll have to create the user. Once the user is actually created, then you are gonna be getting the tokens. So ultimately you will have a token 1 and token 2. Similarly, user ID 1 and user ID 2. This way you will have the things, and after that you will get a few things done over here. First of all, you are gonna be creating the website, then you are gonna be fetching the website. So it's able to fetch website that the user created. So if the user number 1 creates a website, so ultimately it passes the URL, it passes the backend and ultimately all the things, and the same user tries to fetch the website. In both the cases, the data ID should be defined. If that is defined, or you get a response.data.id, if that is equivalent to this, that simply means it succeeded. Ultimately you can just assert the values anyway. It's completely up to you. So this particular thing is done. So ultimately you are creating the website, you are fetching the result. Once the result is fetched, you are just simply checking the result of both, and if that is right, then the job is done. Similarly, cannot access website created by other users. So other users in the sense token number 1, that simply user 1 created this website and user number 2 is trying to access that. So if you actually have a look, so authorization token was token 1, that simply means the user number 1, and then here I provide the token number 2. So you cannot access the websites of the token number 2, hence this particular section is gonna fail. That simply means this particular section is gonna run and it should also succeed. Okay, so these are the things that we have gone through. Pretty simple stuff. So we've talked about test. Test is pretty simple, especially nowadays I'm learning about tests. So now it feels like a quite simple thing. Otherwise I was really scared of even writing tests and all. It didn't really make any sense earlier. Now it is quite simple. Like you have to create the suites. That's gonna be the top level. There can be many suites. Then here just below that you have to have many tests. So you can write test over here. You can write it over here. Both the things are gonna be working. Below that you can have your triple A. You have to arrange. You have to act. You have to assert. And there can be many ways of doing that. But ultimately this is how you are gonna be going ahead. Okay. So this is how everybody, we have got the job done here. We have ready, so we've gone through this as well. And now the front end section is just remaining. So we are gonna be going through the front end section, and overall things are gonna be working fine. Pretty simple, right? Alrighty, so let's simply call it. Now I'm gonna be working on the front end as well. And once the front end is ready, then we are gonna be going through all these things again, and we'll be checking all these things in action. Ultimately, one more thing that is there here in this particular section, ultimately, that whenever you are getting the things from the database and then simply pushing them to the queue, before that make sure that you have consumer groups ready. So consumer groups created, because before pushing to the queue, the consumer groups should be created, so that whenever something gets pushed to the queue, the job gets pushed to the queue, consumer group is actually aware of that, and then using the consumer group you can just simply read. And lastly, after reading, after getting everything done, you have to acknowledge that, so that that actually gets removed from the queue. So if there is a job inside the queue, so of course we are going to be having a job inside the queue, so whenever everything gets done, you have to just simply acknowledge that, so that the job actually gets removed from the queue. So this is how we are going to be going ahead, and that was it for now. Actually we still have to know more, dig deeper into things. We have to just cover many things. We are going to be getting those things done very soon once the front end is also done. Until then, bye bye, take care, and I'm going to be catching up soon. Bye bye.